Okay, hello everyone. Welcome to our presentation in the Enterprise and Software Architecture of BioColombia, a platform dedicated to protecting Colombia's biodiversity. Today we'll talk through how BioColombia addresses the challenge of monitoring endangered species using AI, interactive maps, and environmental impact tools. We'll cover three key stages: analyzing the current enterprise architecture, proposing a new software design, and simulating a technical meeting to justify our decision. Let's dive in. Okay, first, let's analyze how BioColombia enterprise architecture across four layers: business applications, data, and technology. Our goal is to map the current state of as is and propose a future state of to be addresses existing challenges. Okay, in the business layer, the current process relies on manual species identification and reporting via email or WhatsApp with no traceability. This limits citizens' participation and hinders sustainable decision making for researchers, agencies, and companies. Our proposed future state introduces a digital workflow with real-time traceability gamification to engage citizens and dashboards for stakeholders. In the application layer, the as-is states uses fragment systems like Excel, spreadsheets, manual forms, and local databases with no integration. This creates data silos and slows down processes in the to-be state. We propose to the BioColombia platform built on microservices for species registration, maps, and environmental impact assessment, all integrated through an API gateway. For the data layer, data is currently scattered across emails and Excel with no centralization or governance, leading to duplication. Or to be solution centralizes data in MongoDB databases with geospatial support, ensuring quality through governance and enabling real-time analysis. Finally, in the technology layer, the current infrastructure is limited to shared hosting with no CI/CD or scalability. Our future state leverage Google Cloud Platform with microservice deployed in Docker containers, CI/CD pipelines, and monitoring via Prometheus and Grafana. Now, let's move to stage 2. Our software architecture proposal, we chose a microservice architecture for BioColombia because it offers scalability and modularity and seamless integration with external APIs. Let's look at the design of the C4 model. Okay. The context diagram shows BioColombia serving four main actors: citizens who register species via photos, companies assessing environmental impact, and environmental agencies monitoring biodiversity, and researchers analyzing data. The system interacts with external APIs like Google Cloud Vision for AI-based species identification, and Leaflet for interactive maps. Zooming in the container level view includes a front end built in React.js, providing a responsive interactive for users to upload photos, view maps, and access dashboards. The backend, powered by Nest.js, orchestrates microservices for species identification, map rendering, environmental impact calculations, and user management. This communicate through API gateway, We use MongoDB for centralized data storage with geospatial capabilities and RabbitMQ for asynchronous event handling like alerts for endangered species. Um, our design improves in the business process by automating a species identification with an 85% accuracy, as shown in our MVP, and proving real-time traceability via maps. It replaces fragmented systems with an integrated platform, connecting to external systems like wildlife insights. Data is managed centrally in MongoDB, eliminating silos, and the cloud infrastructure ensures scalability and maintainability. Finally, in the stage 3, our technical meeting simulation, let's present the enterprise architecture model and justify our decisions. The visual model summarizes the current state, issues, and proposed solutions. In the business layer, manual processes and low citizen engagement are addressed with a digital workflow and gamification. In, in applications, we replace silos with microservices integrated via an API gateway. For data, we centralize in MongoDB and governance. And in technology, we move to a scalable cloud infrastructure with CI/CD. Now let's discuss risks and trade-offs. One risk for the AI's lower accuracy for rare species will be mitigating this by training models with more data from environmental partners. Another risk is map performance with large data sets, which will address with query optimization and caching. Low citizen adoption is a concern, so we'll be focusing on user-centered design. Finally, cloud costs could be high, but will optimize resource usage for trade-offs, microservices, increase complexity, but provide critical scalability. Cloud infrastructure depends on internet access, but supports growth. Using external AI like Google Cloud Vision saves time but introduces costs and dependencies justified by faster implementation. In conclusion, BioColombia's enterprise and software architecture transforms biodiversity monitoring by replacing manual processes with a scalable, integrated platform or microservices design built on React.js, Nest.js, MongoDB, and Google Cloud ensures efficiency, traceability, and citizen engagement, aligning with Colombia's biodiversity conservation goals, as outlined in Law 2111 of 2021 and Resolution 1912 of 2017. Thank you for watching, and we're excited to bring BioColombia to life for a sustainable future.